Okay, so in this video on area and volume, I'm going to have a look at some questions revolving around cylinders, spheres, cones, and cuboids. So let's have a look at this question first. This one here involves a cylinder. I'm going to say the cylinder here has a radius of, let's say, 10 centimeters. So R here is equal to 10 centimeters. Now, what we're going to do is we're going to say that there is a certain amount of water in this cylinder. So it looks, let's say, like this. So this is water here. Now, what we're going to do is we're going to take a let's say a sphere, and we're going to put the sphere into the water. So the sphere is going to end up here, and again the sphere has a certain radius. So we're going to say the radius of the sphere. Let's say the sphere has radius, let's say 5 centimeters. 5 centimeters. So this is our sphere, and this here then is our cylinder. Okay, so the idea is that the water here, when you put the sphere into the water here, the water is going to rise, and let's say it rises to this height here. So it's risen this distance here. So the water has gone up this distance. So the question here is, how high has the water risen? What's this distance here? So from here to here, we'll call it H. How high has the water actually risen? Okay, so let's start then. So what we need to do here, first of all, is we're going to find the volume of this sphere that we put into the water. So we're going to look at the volume of the sphere. And the volume of a sphere is given by the formula 4 over 3 pi r cubed. So if we take the 4 over 3, we multiply it by pi, we multiply it by the radius cubed. Well, the radius of our sphere is 5, so we're just going to put 5 here and cube it. Okay, so we're going to do this. Now, if you take your 4 over 3, I'm just going to quickly do this on the calculator. We want to multiply that by 5 cubed. We get 500 over 3. So I'm just going to leave it as a fraction for the moment. 500 over 3 times pi. And this is in centimeters, so our answer here is just going to be in centimeters cubed. Now I'm going to leave the pi as part of the answer. You could multiply 500 over 3 by pi, which is 3.1415 and so on. But I'm just going to leave the pi in here, and you'll see why in a few minutes. Okay, so we put the sphere into the water. The water has risen by this amount here. So what we're going to do now is look at this part of our water here. Just this part here. We're going to look at this part here, which is actually a cylinder. The water here is actually in the shape of a cylinder, so you can imagine that it looks like this. This is by hand now, so it's a little bit rough, but okay, so it's going to look something like this. This is going to be our H here. So this is the part of the water that's actually risen. So again, we have the same radius as our cylinder. So this is 10 centimeters here. So really we know the volume of this part of the water here. We know the volume is 500 over 3 pi centimeters cubed. It's in the shape of a cylinder. So we know that the volume of a cylinder is pi r squared times h. We know the volume of this cylinder here, this water cylinder if you like. We know that it's 500 over 3 times pi. On this side then we've got pi. We've got r, which we know is 10. So that's going to be 10 squared. And then we have to try and find h. So we have this equation here, and we've got to work out what h is. Well, you can see now why I left pi as part of the original answer here when I worked out the volume of the sphere, because we have a pi on this side of the equation, we have a pi on this side of the equation. So we can divide, and it's multiplied, by the way, in both sides, so we can actually just divide across by pi. So if we divide this side by pi, we get 1. If we divide this side by pi, we'll also get 1. So what we're actually left with here is 500 over 3, which is equal to 10 squared, which is 100, times h. So what I've got to do now is just divide both sides by 100. So if I divide the right-hand side by 100, I get h. Divide the left-hand side by 100, and I'll just get, this is 500, I'll just get 5 over 3, 5 over 3. Okay, so, and this is centimeters here, okay, so the height that the water has actually risen is 5 over 3, 5 divided by 3, which is 1.6. If we wanted to one decimal place, for example, h would be approximately equal to 1.7 centimeters. And that's really it. That's how you would work out the height here. Okay, let's have a look at another question. Okay, so in this case, we're going to look at a sphere. So we're going to have this sphere here. Doesn't quite look like a sphere, but you get the idea. And we have a radius here as well. I'm going to say the radius of this sphere is 6 centimeters. And what we're going to do is we're going to, let's say this is a wax sphere. We're going to melt down this wax sphere. And what we're going to do is we're going to make a cone. So the cone will look something like this. So this is our cone. And we want the radius of the cone to be 10 centimeters. So the radius of our cone here is going to be 10 centimeters. So that's the radius here. Here our radius is equal to 6 centimeters. Now, what we want to do, the question here is to work out the height of this cone here. So we want to work out this distance here, the height of our cone. So we'll call this h. Okay, so what do we know? Well, we know that if we melt down this sphere and we turn it into a cone, that the cone will have the same volume as our sphere. So again, the first thing we've got to do is work out what the volume of our sphere is. So the volume of a sphere, again, is 4 over 3 times pi or cubed. In this case, we've got 4 over 3. We leave pi as pi, and our radius here is 6, so we want to multiply by 6 cubed. So again, let me just quickly work that out on a calculator. So it's 4 over 3 times 6 cubed, and that will give me 288. So that's 288 pi, and that's centimeters cubed. So that's the volume of our sphere. Okay, so let's have a look then at our cone. So we know that our cone then is going to have this volume as well. So the volume of a cone is 1/3 pi r squared h. So we know that the volume of our cone here, we know the volume of our cone is 288 pi, because it's the same volume as the original sphere. So we're going to, on the right hand side, write down 1/3 times pi times the radius here we know again is 10. So we're going to multiply by 10. We've got to square that and then multiply by h. So again, as with the previous question, we've got a pi on this side multiplied by the 288. We've got a pi on this side multiplied by everything as well. So we can divide across by pi. So I'm going to divide this side by pi. That'll give us 1. Divide this side by pi. That'll give us 1. So we just simply end up with 288 is equal to 1/3 times 10 squared, which is 100, times h. Okay, so what we end up with here then really is 288 divided by 1/3 divided by 100. So we divide across by 100 and divide across by 1/3. So if you divide 288 by 100, for example, we get 2.88. That's equal to 1/3 h. And then finally we want to divide by 1/3 or multiply both sides by 3. and we get 8.64 centimeters. So the height of our cone will be 8.64 centimeters. And that's it for that question. Let's move on to the final question then, which is a volume question, but it involves it's a flow type question. So in other words, what we have is we have this cylindrical pipe, which looks something like this, let's say. And through this pipe then you've got water flowing, and it's flowing into a cuboid or a rectangular tank, if you like. So it's going to flow into this tank. Okay, so we have our tank here, and let's say the water here is flowing in this way. Let's say the water flows at a rate of 10 centimeters per second. So 10 centimeters per second. So every 10 centimeters of water that flows through the pipe, that represents 1 second of water coming out this way. Now the radius of this pipe, let's say, is it's 4 centimeters. So R here is equal to 4 centimeters. This is our radius here. Okay, now the tank as well has dimensions, and that has dimensions, let's say 60 centimeters in length, 60 centimeters this way, and let's say 20 centimeters width here. Okay, so the idea here is to work out how deep the water will be in the tank after 1 minute. So let's just fill this bit out as well. So again, you're going to end up with water in the tank, and let's say it ends up here like this. So we want to know, so this is all water after 1 minute. We want to work out this height here. How high will the water be after 1 minute? Okay, so what we've got to do first really is just look at our cylindrical pipe. So our cylindrical pipe, I'm just going to draw over, I'll draw it down here. And I'm going to just draw it like this. Actually, let's do it in white again. So we have our cylindrical pipe, and I'm just going to take 10 centimeters of that pipe. So I'm not going to take the full pipe, just 10 centimeters of it. And we know the radius here is 4 centimeters again. So this here is 4 centimeters. So what I'm going to do is work out the volume of a 10 centimeters section of this pipe. So the volume of a cylinder is pi r squared h. So in this case it's going to be pi times the radius squared, which is 4, so that's 4 squared, times, now the height of this cylinder here is actually 10 centimeters. If you just flip this up, you'll see that the height is 10 centimeters, so we're going to multiply by 10. And when we do that, we get 4, 4, 16. 16 times 10 is 160. And we leave the pi as pi for the moment, and that's going to be in centimeters cubed. Okay, so that's the volume of water that happens to be in 10 centimeters of the pipe. And why did we do 10 centimeters? Because we know that every 10 centimeters represents 1 second of water that flows into our tank here. So this volume of water here flows into the tank every second. Okay, so what we want to know then is how much water will flow in after 1 minute. So after 1 minute, or in 1 minute, I should say really. So in 1 minute, 160 pi times 60 seconds will will flow into the tank. So in 1 minute, this is how much will water in centimeters cubed will have flown into the tank. Oh, okay, so let's just multiply that out. So we have 160 times 60, let's say. That'll give us 9,000. So that's equal to 9,600 pi centimeters cubed of water will be in the tank. So now if we go back to our diagram, we now have the volume of this blue area here. We now have the volume of water in the tank. We have the width, we have the length. What we don't have is the height here. So to find the volume of this water here, we multiply length times width times height. So that's 60 times 20 times h, and that should give us this number here. So in other words, the volume of water in the tank is just length times width times height. So we know the volume of water in the tank. It's 9,600 times pi. I'm actually going to work that out. So I'm going to multiply the 9,600 by pi, and I'm just going to round it to let's say 2 decimal places for the moment anyway. So it's 30159.29 to 2 decimal places, and we want to let that equal to length times width times height. Well, we know the length is 60, the width is 20, and the height we don't know. So all we've got to do now is just solve this equation for h. So we have 30159.29 is equal to, well, 20 times 60 is just 1,200 h, and finally then our h here will be this number here, 30,159.29 divided by 1,200. So if you do that, and again I'm just going to round to 1 decimal place. Let's say the question asks for the answer to 1 decimal place. So the answer here would be 25.1 centimeters. So in other words, this height here, the water would have risen by 25.1 centimeters. And that's it for this particular video.